Also, unter Next Generation Computing verstehen wir
When we talk about next-generation computing, we ultimately mean three new forward-looking capabilities:
die Vertrauenswürdigkeit von
the trustworthiness of
Elektronik und von
electronics and of
Systemen,
computers,
die
and improved computing
Steigerung der
performance,
Leistung, gleichzeitige
coupled with the reduction in power
Reduktion des
consumption,
Stromverbrauchs.
and the resources required to make and operate things. We focus on three main areas of research. One is trusted electronics in the sense of hardware identity.
Hardware-Identität, sicherzustellen, dass
This lets us ensure that electronics are authentic.
Das heißt, dass
In other words, that when a computer communicates with other machines or with humans, its identity is the one its communication partner is expecting.
hat, von der sein Gegenüber ausgeht.
Second, computers must be powerful with regard to performing calculations,
Durchführung von
especially when it comes to artificial intelligence and the application of neural networks.
von neuronalen Netzen geht. Das nennen wir sogenanntes Neuromorphic Computing.
We call that neuromorphic computing, where we mimic the use and function of processing mechanisms and also the architectures in the human brain, neurons and synapses and the like.
Ja, und der dritte Punkt, der uns auch beschäftigt, ist dieses
And our third key topic is quantum computing, which everyone is talking about right now.
Und, es werden viele
It also
Menschen
features
darauf
prominently in the political debate.
gelingt, mit der
There are high hopes that it will be possible to use quantum superposition and entanglement to build new computer architectures and new computers that will one day be able to demonstrate what's known as quantum supremacy.
Das Fraunhofer IS ist an der Stelle
Fraunhofer IIS is making contributions to the research community.
Das ist zum einen
It's about going to a deep level to connect individual quanta to the outside world. In other words, building electronics that help address, precondition, and then read the responses of individual quanta. Essentially, it's a question of interfacing technologies.
Die Quanten als solche, das ist eine grundlagenphysikalische.
The quanta themselves are basic physical phenomena, and we're actually less concerned with them.
berührt sind, aber dieses Interfacing,
But this interfacing, where you generate electromagnetic fields that can then detect, address, and change the quantum spins, is a classic task for microelectronics. The question is how to build such circuits, how to incorporate corrections, and then how to get to the point where you can make the functions of a qubit or qubit system available to higher software layers. That's an area that the IIS is researching. Then, relatively high up in the application hierarchy, you have the development of optimization algorithms that quantum computers are also proficient at processing. We're talking about certain mathematical optimizations. This is the job of our colleague Alexander Martin in Nuremberg. He's applying his expertise as a mathematician to research how to prepare algorithms in such a way that they are suitable for quantum computers and can be processed by them, so that we can evaluate what exactly the advantages and disadvantages are.
Ja, und daran arbeiten wir am IIS.
These are the topics we're working on at the IIS together, with a wide range of partners at Fraunhofer, and also with our partners from industry. We see this as an important contribution to progress as a whole, to future capabilities for users from industry, and of course, to technological sovereignty in Germany and in Europe.
In Deutschland und in Europa.